Hello, this is another tutorial to show you how to do multiplication in PIC microcontroller. So there are two instructions. One of them is the RLF, which has two operands. It has F and D. This instruction is called rotate left F through carry, and there is another function or instruction which is called RRF, which has two operands F and D. It is rotate right F through carry. Now in binary, multiplication and division can be implemented by moving or shifting the binary bits either to left or right. If you would like to do multiplication, we shift it to the left, or if you would like to do a division, we shift it to the right. Let's say, for example, if we have an expression is equal y equal 4x. This means we multiply x with 4. In binary, it means we shift the constant x or the variable x to the left by 2 bit, to shift or 2 bit. For example, if x is equal to 0, 0, 1, 0, 0, if we would like to multiply it by 4, we will shift it to 2 locations, which means it will be something like 0, 0, 0, 0, 1, 1, 0, 0, 0, 0, 0. If you notice that we have shifted the ones, these two ones, into to shift. So to shift means this, the first one will be 1, 2, it should be here, and the second one should be 1, 2, should be right there. Okay, so this should be like this. No, 0, this one. So y equal 4, it means in other way it's 2 to the power 2 2 to the power 2, we don't have power, 2 to the power 2 times x. If you would like to, for example, multiply 8x, it will be 2 to the power 3 times x. So we do 3 shifts. If you would like to multiply by, for example, 9x or 7, let's 9x, it will be equal 2 to the power 3 times x plus x, which is equal 8x plus x. So we shift 3 times and then we add x again. For division, it's the same, but instead of shifting to the left, we shift to the right. So if we'd like to, if we have an expression like y equal x divided by 4, so divide, it would mean we shift to the right 2 times. So it's x divided by 2 to the power 2. Alright. Same thing if we like to divide x divided by 8, it would equal to x divided by 2 to the power 3. So we shift to the right 3 places. So let's give it a try. Let's write a code where we have y equal 4x. So initially we need to write include p16 f877a.inc org00 n. Then we need to define a constant using C block 0x70. Then we have x, and when we have y and c. Let's say we would like to define x as 3. So we would say move LW decimal 3, then move WFX. Now we need to multiply x by 4, so 4 times 3 it will be 12. Now we need to do 2 shifts, so we need to do it this way. We need to make a loop and go to loop. Then we would say RLF x comma f. So we rotate to left and we return it to the x, but we need to check something. We need to check bit test file decrement file skip f0. We need to define another constant that will show us how many shifts we will do. In our case, we'll do 2 shifts, so we define, let's say, we'll call it count, and in this count we say move LW decimal 2, then move WF count. Now we decrement file skip if the decrement file skip f0, or we have it decrement file skip f0 count, and we have it on itself. So it will do the first shift. Notice that this is a loop, so it will do a first rotate, and it will move let's say the first rotation will be like this. It will be initially x, it's 0 0 0 0 and 3 0 0 1 1. So when the first rotate, it will be 0 0 0 0 0 1 1 0. Then the second rotate will be 0 0 0 0 0 0 1 1 0 0. This will be 12 for 8 times 4 plus 4, it will be 12. So let's give it a try and see what's the value of x. We just save it and build it. We have some bugs here. Error. Oh, there are many errors. Okay, so what's going on? Oh, sorry, this NC should be like this. We just build it again. Now we have one error, illegal count. We don't have count here, so we have to define it in count, count. We count, so it would say illegal opcode. It should be like this, maybe. Let me check. Debug. No. Decrement file, skip, no, decrement file, skip F0, yeah, sorry. Should be like this, yeah. Now it's gonna work. Alright, so now it's working. Let's give it a try and run it. No, it's running. Let's pause it and do a reset. Then we need to go to Windows, the file registers. File register, we go to the symbols in order to define the locations of the X, Y, and the count. Before we do that, after we finish, we need to move F, X into W, then we move WF into Y. So we need to move the operation, the calculation, into Y. Let's run it again. File register, we need to go to the memory location 70. This is where we have X, Y, Z, X in 70, Y in 71, and count in 72, based on the C block. Start with 70, so X 70, 71, and 72. So let's do now the operation. We have, let's pause it. Oh, it's not running. Let's just run it. Now, registers again, we get back. Here. Now, debug, pause, reset. Okay, so now initially let's press F7. So we now 70, X is 3, and 72 would be 2. Now we will do the shift. So the first shift will make X equal 6. Go to the loop. The next shift will make X 12. Then it will jump and it will move 12 to W. So now 71 is 12. So this is how we do multiplication. This, for example, we need to do X plus 9X. 9X is just, we need to add extra x. So here we need to, after we do the count, we go here and we will say add let's say x. So x, now we will say first of all, yeah, we need to define x in some other place. We call it temp x. So we need to keep the original value of x, which is 3. Now we will say move wf temp x. Let's say we want to do 9x. 9x, that means we have 2 to the power 3 plus x, which means we need to change also the number of shifting. We have to make it 3, and here we would do so now we have a temp x in, it's already reserved. Let's say now we need to move f temp x into w, then we want to add wf with x, and we put it on x, on f, and then now we need to add w. So now then we move w to y. So now here we have 9x. So 9x means we do a 3 rotates, then we add the extra x at the end, same as in this equation. Where's 9x? It's 9x. So we do a 3 rotates, and then we add x. So let's run it. That means if we have 9x and x is equal to 3, the result of y, 9 times 3, that's 27. Let's check. Pause. Reset. Let's go to 70 and 71. Actually, if you see, it's already 27 here, but let's give it a try. So F7, now we have 70 has 3, and temp x, it has also 3, it's in 72. Then we have count, we have 3 counts. This is the one, 73. So now we rotate 3 times. So we have 6, 12, if you notice 70. Then we have the last rotate is 24. 24 will jump, and then we'll add the temp x, that's 27, and then it will move it to y, which is right here. So 9 times 3, that's 27. So this is how we do the multiplication. In the next video, I'll show you how to do division. Thank you, and have a good day.